In this section, we're going to talk about finding the standard deviation of a binomial. And remember, a binomial is any probability problem or any problem where you can define the outcomes as success or failure. Um, so, this problem, when throwing a dart at a carnival, the average player has a 5% chance of getting a prize and a 95% chance of not winning at all. What is the standard deviation for the game when throwing 20 darts? All right, well, you may remember in a previous section we learned that the expected value of a binomial is n times p, where n is the number of trials and p is the probability of success. So let's define this scenario to be success being winning a prize. Okay, well, because typically that's your goal when you're trying to play a game. Not very many people like to say, I'm here to lose, but you never know. Anyway, so therefore, the probability of winning a prize is 0.05, so that's what we'll go with. So in this problem, the expected value would be 20 times 0.05. And because I purposely made up these numbers to do this, this would be 5/100ths. Hey, look at this, which is just going to be 1/20th. Magic! So that leaves us with 1. So therefore, the expected value is 1, which means what is the units? We would expect to win 1 prize when you're throwing 20 darts and you have a 5% chance of winning. Okay, that being said, we now need a formula for standard deviation. And the standard deviation formula is actually quite simple. It's just n times p times q and the square root of all of that. So similarly, the variance of a binomial would just be this whole thing squared. So it'd just be n times p times q. Okay, so this would be variance. But we don't care about variance. All we care about is standard deviation. So how would I find the standard deviation? Well, n is 20, p is 0.05, and q is 0.95 because it's the probability of losing, right? And so therefore, yes, every single time that number and that number, it must add up to make 1, right? Because that would be 100% of your outcomes. So then we're going to take those values, multiply them, take the square root, and we now have a standard deviation. The standard, in highlighter. The standard deviation is 0.9746794,345. Okay, and what does that mean to me? What is that saying? Well, if our expected value is 1, then that means if we go up 1 standard deviation or down 1 standard deviation, we're basically going to be at, like, what down here is 0.03 or 26, and then up will be 1.97ish. And so what we're saying is, if we're normal, and we'll really define that in the next video, what normal absolutely means, and we'll go through that. But assuming we're closer to bell-shaped, symmetric, and nice and pretty, we're saying that 68% of the population, when they play this game, will fall somewhere between 0 prizes and 2 prizes when they're throwing 20 dice, or darts, whatever you're throwing at the board. Now, this is kind of one of those little fun games of going down 2 standard deviations. What does that mean? You are losing prizes. You are now in the negatives. The number of prizes you will win, you're going to be so bad at the game, they're going to start taking prizes away from you. No, that's not what it means. That just caps off at 0. But then you're going to say it's 2 standard deviations going up. Will now put us at 2 point, whatever it would be, 94-ish, or whatever. Yeah. So what does that mean if we're going up another 0.9 and change? Well, that means that our second standard deviation is going to win somewhere up to 3 prizes, just about 3 prizes. That gets us to the 99%. 68, 95%. So if this is 95% of the population, I'll write it up here, 95% of the population, that means 95% of the people who play the game are going to win somewhere below 3 prizes. And then once again, we're going to go up another 0.9 and change. So that let's just call it, 3. 3.91 or whatever it would be. I totally forgot what the number is at this point, but it doesn't really matter because I'm just trying to make sure you understand the idea here of, well, all right, so you added on another 0.9746, blah, 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 blah. So that means within 3 standard deviations, you're gonna have 0 people, 0 prizes up to about 4 prizes. So if it costs $5 to play the game, right, and each prize costs you $1, even if you give away 4 prizes, you're still on the positive as far as that goes. You got to pay your person who's running the booth, but if it's a charity booth or something like that, you're not paying anybody anything. There you go. So this is kind of how you evaluate this type of game, and you can figure out where your break-even points are and that kind of fun stuff. All right, hope this video enlightened you and made you feel awesome. We'll see you in the next one.